picking up good vibrations.
Some properties of signals. A signal can be even or odd. It is even if x of t is equal to x of minus t in continuous time. It is odd if x of t is equal to minus x of minus t. Even means that it is symmetric along the signal axis. If the signal axis is y and the independent axis is t, it is odd if it's symmetric along the axis y equals minus t. Given any arbitrary signal, we can always decompose it as an even plus an odd signal. The even part is x of t plus x of minus t over 2, and the odd part is x of t minus x of minus t over 2. If we add up these two signals, we end up exactly with x of t, and in this sense, it is a partition of x of t. How do we know that each of these signals is respectively even and odd? Just by definition. You can consider the signal x of t, for instance, the even part x of t plus x of minus t over 2, and see that if we replace t by minus t, we get exactly the same signal. In this sense, the signal is even. Here are a few examples. If we take the even part of the exponential e to the power of t, we get the hyperbolic cosine, which is an even function. If we take the odd part of exponential of t, e to the power of t, we get the hyperbolic sine, which is a odd function. Another example in discrete time is, what if we take a function that is only non-zero for positive n? Once we take the even and odd parts, we also get signals that are not zero for negative time, but if we add them up, they will cancel for negative n. Another important property of signals is periodicity. A signal is periodic if x of t equals x of t plus capital T for some capital T. Take, for instance, sine of t. Sine of t fits this description with capital T equals 2 pi, 4 pi, 6 pi, etc. So there's not only one period of a signal, there's only one fundamental period, and that is the smallest of all these periods. In the case of a sine, it's 2 pi. Often we just say the period of sine of t is 2 pi, but to be rigorous, we should say the fundamental period of the sine of t is 2 pi. Here are also some examples: a rectangular wave and a train of impulses. Now, be careful, because in continuous time, a signal taking the form of a times sine or cosine of omega naught t plus a given phase phi is periodic for any omega naught. However, in discrete time, a signal taking the same form, but now written as a times cosine of capital omega naught n plus phi, is only periodic if capital omega naught takes the form 2 pi times an integer over an integer. This is going to play a big role in our course later on. If a signal is not periodic, it is said to be aperiodic.